So for this problem, we are given a transfer function, and we are asked if a 30 hertz signal will pass. Okay, so the first thing that we need to do is to find the magnitude of the transfer function. So the first thing to simplify that I'm going to do is to divide both sides by omega. So I will have R1 plus R2 times J over R1 plus R2 over omega plus J times C. And if I find the magnitude of this transfer function, then I need to find the magnitude of the top and the magnitude of the bottom. So that gives us R1 plus R2 squared, since we only have the imaginary part. And then we have R1 plus R2 over omega squared plus C squared. Okay, and so of course here we can write this like this. And if we want to think about the behaviors of this transfer function, okay, as omega equals 0, then we know that this is undefined, and we know that as omega goes towards infinity, that this term will go to 0, and our magnitude will just be R1 plus R2 over C. So then the behavior of our transfer function is something like this. Okay, so now we want to know if 30 hertz will pass through. So now what we know about the cutoff frequency omega C is when we are at that frequency that our magnitude will be equal to our maximum value over the square root of 2. Okay, so this property is important. So since we know what this value is, okay, and we have an equation for this, we can set them equal. All right, so we're going to write R1 plus R2 over the square root of R1 plus R2 over omega C squared plus C squared is going to equal that R1 plus R2 over C, all of that divided by square root of 2. Okay, so let's substitute some values to simplify this a bit. Okay, so R1 plus R2 is 15. And so this will be 15 for omega C squared plus 1/4 squared is going to be 60 over the square root of 2. Okay, so now we can do some manipulations to figure out what omega C is. Okay, so what I'm going to do is just to go ahead and divide both sides by 4 so that this is equal, and then I can set the denominators equal to each other. Okay, square both sides. Okay, then I'm going to subtract and divide. And then I'm going to solve for omega c, and it equals 60. Remember, this is radians per second. Now I want to know if 30 hertz will pass, so I'm going to make this into hertz. So FC is going to be 9.54 hertz. Now again, going back to our graph, okay, we're looking at this kind of behavior, and we're saying that for an ideal, that the cutoff frequency is going to be that 9.54 hertz. So what we know is that 30 hertz will pass because it is greater than that 9.54 hertz for your cutoff frequency.